Section 7.5 is percent of change. I can find a percent of change in a quantity. A percent of change indicates how much a quantity increases or decreases with respect to the original amount. If the new amount is greater than the original amount, the percent of change is called the percent increase. We started somewhere, got bigger, that's an increase, so it's a percent of increase. If the new amount is less than the original amount, the percent of change is called the percent of decrease. So we started somewhere, the number went down, or the amount went down, so it was a decrease, smaller. We're going to find percent of change whether it's increasing or decreasing the same way. The percent of change is the ratio of the amount of increase or decrease to the original amount. So we're going to find the amount of increase or decrease, our change, and we're always going to divide by our original amount. So to find our change, we're going to subtract. We're going to take our bigger number minus our smaller number. So in example 1, the International Balloon Fiesta takes place every year in Albuquerque, New Mexico. In 1999, 903 balloons participated. In 2000, 1,019 balloons participated. By about what percent did the number of balloons increase from 1999 to 2000? So again, we're going to take our change divided by original. To find our change, we're always going to take our bigger number minus our smaller number. So here are two values, 1,019 minus 903. There I get 116. And I'm going to divide by my original. And if we look here, we increased from 1999 to 2000, which means 1999 is our original year. So we're going to look at our value there, and it's going to be the 903. When I divide here, I get approximately 0.128 something. And we want to know by about what percent. So to switch that into a percent, I'm going to move my decimal places 2 places towards where my percent sign goes. If I'm going to add a percent sign, I'm going to move it towards that, 12.8%. And since we want about what percent, we're going to round to the nearest percent, round up since it's higher than 5. And it's about 13%, and that is a percent increase because it went from about 900 to about 1,000. So a 13% increase. Okay, so feel free to stop here, pause here, and give these a try if you'd like. We're going to find the percent of increase. So again, it's going to be our change over our original amount. So to find our change, we're going to take our bigger number minus our smaller number. Here we get 5, and then divide by our original, which is where we start here, 20. When we divide, we get 0.25, and we want to find the percent of increase. So it's going to be 2 places towards where our percent goes, 25%, and we're going to label that increase. Because we started at 20 and went to 25, our number got bigger, means it's an increase. Same idea for number 2. Again, we're going to find our change, so bigger minus smaller, divide by where we started, original. So our change here is 39 divided by 150, and that's going to give us 0.26. 2 decimal places towards our percent sign to add a percent sign, and it's a 26%. We went from 150 to 189, got bigger, so it's an increase. Again, we're going to find our change. So 143 minus 55, bigger minus smaller. Here that gives me 88. And I'm going to divide by the original, which here is 55. It's going to give me 1.6. So my ratio is 1.6, but I don't want ratio, I want the percent. So we move 2 places towards where our percent sign goes, and it's 160%. And again, that's an increase because it got bigger, so we label it as an increase. In example 2, we're going to find the percent of decrease from 512 to 320. So here we're looking for the percent of decrease because we went from a big number to a small number, from 500 down to 300. We're going to find it the same way. We're still going to take our change divided by our original. So to find our change, we're still going to take bigger minus smaller. Here I get 192. And I'm going to divide by the original. And I decreased from here to there, which means this is where I started my 512. And again, it's always by where we started. When I divide here, I get 0.375. And we want the percent. So 2 places towards where my percent sign goes. 37.5%. And since I started at 500, went to 300, this is a decrease. Okay, feel free to pause here and give these a try if you'd like. To find the percent of decrease, we're going to take our bigger number minus our smaller number. And then we're going to divide by the original, which here is 20, where we started. And we get 0.25. Again, to find our percent, we're going to move it 2 places and add our percent sign. So 25%. This is a decrease because we started at 20 and got smaller. Our number went down to 15, so down means a decrease. Same idea though, we're still going to find our change, and to find change we subtract to find our difference. Bigger minus smaller. And then we take that and divide by where we started, the original. Here, I'm going to get 0.5333 repeating. To write that as a percent, it's 2 places, and we add our percent sign. So 53.3%. This is a decrease. Make sure we have that 0.3 repeating. We want it to be the exact amount. So 53.3 repeating percent. Also, don't put your repeating over your 3, put it after your decimal so that we can see that it's our decimal that repeats, not our ones digit, which I know are the same number. But to make sure it's in the right place, we put it in our decimal place, and then our decimal continues. Again, to find our change, we take our bigger number minus our smaller number and divide by where we started. When we subtract here, we get 51 divided by where we started, 102, the original. We get 0.5, but we want the percent. So 2 places and add our percent sign. 50%, and since we started at 100, went to 50, this is a decrease because our number went down. If we know the original amount and the percent of change, we can find the new amount. First, we're going to multiply the percent of change by the original amount to find how much change there was. And then we're going to increase or decrease the original amount by the amount of change. So, and that sounds like a lot, guys, but we're just going to take it one step at a time and do it the same way that we have been doing these. In example 3, there were about 198,000 spectators at an action sports event in 1995. The amount of spectators increased by about 12% from 1995 to 2002. How many spectators were there in 2002? So what we've been doing, guys, is we've been taking our bigger number minus our smaller number, dividing by our original, and that gives us our decimal that we turn into a percent. We're just going to work backwards now. We're going to plug in what we know and go from there. So here we know 12%. So 12% as a decimal, we get rid of our percent sign and move it 2 places away from our percent sign. Since we got rid of it, we move away. Now, we know that in 1995, which is our first year, there were 198,000. That is our original. It says that that number increased by 12%. So that means that this number is where we start, and then we add on a number. So the second number is going to be our bigger number. That's what we're looking for. Minus our smaller number is going to be the 198,000. And because I've filled in every gap except bigger, that's where my variable goes. Now, to solve this equation, I have to get rid of the division first. So I'm going to multiply both sides by 198,000. Get x minus 198,000 equals 23,760. Now, to get x by itself, I have to add 198 to get that to be 0 spectators on that side. Okay. Oops. X equals 221,760 spectators. So we're just undoing the steps that we take when we find the percent change to find the other amount. Here, we're going to find the new amount. So we increase 45, so 45 is where we begin, by 20%. So that 20%, I'm going to get rid of my percent sign, move it 2 places, and get 0.20. Because remember, we took bigger minus smaller divided by the original, and that gave us our decimal that we switched to a percent. So now we're going to switch our percent to a decimal and fill in what we need. So we know we're still going to subtract here. We increased 45. So does that mean 45 is bigger or smaller? It means that 45 is going to be the smaller piece, because to increase it, that means we added to it. So we're looking for a new amount, and that's going to be our bigger value. First step, get rid of division by multiplying. To get x by itself, we are going to add 45. And we get 54. So the new amount was 54. Same idea here. We're going to decrease 85, which means we started at 85, and we're going to decrease it by 28%. So to get rid of our percent sign, we move it 2 places and set it equal to our ratio. Again, we go from percent to decimal. We know we're subtracting bigger minus smaller. So if we're decreasing 85, that means 85 is bigger than what we're going to get. Decrease means we're going to bring it down. So we're going to start at 85 and get a smaller number. First step here is we're going to multiply by 85. To get rid of the division, we have to multiply. Here we get 23.8. Now, if we look, our 85 is being added to a negative x. It's positive 85. So to get rid of it, we have to subtract. We're trying to get that 85 to be 0. So if we have a positive 85, okay, if there's not a sign, remember it's positive, we have to subtract to get it to 0. And we take the sign in front of the number with our number. Here we get a negative 61.2. Last thing here is our x isn't all the way by itself. Remember, if there's not a number in front, it's a 1. So right now it's being multiplied by -1, so we're going to go ahead and divide by -1. And our new amount is going to be 61.2. I'm going to go ahead and stop here, and finish out our last example on a new video.